So in this gate question, this is a gate question from 2016, and in this you were supposed to find the number of topological ordering for this graph. If you don't know what topological ordering is, it is basically about finding the sequence of nodes in which if you traverse, you will be traversing in the given direction. And when so in this question you have to traverse from A to D by, but you have to go through each and every nodes in the given sequence itself. You cannot jump from one node to another. For example, from A you cannot directly access node F, so you have to find the number of such orderings in which this sequence is maintained. So whenever you have to traverse from to C, you have to go through B. So in your traversal, if there is a path from A to C, B should always be in between A to C. So how do you find the number of such nodes? So you can, as you can see, the starting and the end point is fixed, and you have three spaces in between for these four nodes. So if we start filling up the first place with B, we have about total of six possible paths, but not all these paths from A to D will be valid. So the first path from A maintains the order that B is traversed before C and E is traversed before F, whereas this one does not maintain this ordering of the sequence, that is sequence of nodes that is required. In this, F is accessed before E is accessed, so this path will be invalid. In the same way, out of this total six paths that are starting from with B, you can see there will be half the cases where E will be before F and half the cases where F will be before E. The ordering of B and C has already been maintained when you are starting with B. So all the three places, if C is present in any of the three places, it will always be after B. But the only ordering that needs to be maintained is of E and F, and half the cases will have E before F and half the cases will have F before E. So out of this total of six paths that are starting with B, three of them will be invalid and three of them will be valid. The number of ways in which these four blank spaces can be filled is 4 factorial, so which comes down to 24. As you can see, the four factorial paths can be broken down into those starting with B, those starting with C, those starting with E, and those starting with F. I have written down the sequence of orders for when starting with B. It comes down to 6 paths. And similarly, you'll have those starting with C, 6 paths, 6 paths for those starting with E, and 6 paths for those starting with F. Out of this, whenever you are starting with C, of the 3 places that are remaining, if you place B anywhere, whenever you are starting with C, if you place B anywhere, this path will always be invalid. So those paths that are starting with C and those which are starting with F will always be invalid. So out of total of 6, only 3 of them are valid, and out of the total of 24, half of them are already invalid. So you have 3 from here and 3 when you are starting with E. Even in this, there will be, out of this 6, there will be 3 cases where you will have C before B. Out of these 6 cases, you will have 3 of the cases where C is before B and 3 of the cases where B is before C. So the total number of ordering that are possible out of this 24 possible paths, you can say 3 are available in this group and 3 of them are available in this group. So that will be a total of 6 paths. The another way in which this can be done is by thinking of it as this way. So out of total 4 factorial paths that are possible, only uh, there will be 2 factorial orderings in which C comes before B, and there will be 2 factorial ordering in which F comes before E. So if we divide 4 factorial by 2 factorial and 2 factorial twice, that will be our answer of finding the number of topological orderings for this graph. In general, it is not possible to give a formula for finding the number of topological ordering for a particular graph. You need to do it on a case by case basis. Thank you.